Yeah, Madam Pallavi is there online with us.
Okay.
Madam Pallavi?
Sir.
Yeah, she will introduce.
Good morning, one and all.
Yeah. Go ahead,
Good
madam.
morning, one and all. Respected Principal Ma'am, my dear colleagues, honorable guests, and other participants attending the webinar. Good morning, all of you. I am Pallavi, lecturer in Political Science, GDC Pithapuram. I would like to take the opportunity to introduce Dr. G. Sahaya Baskaran, Associate Professor of Physics, Andhra Loyola College, Vijayawada. Some of his research achievements include being admitted as an Associate Fellow into the AP Academy of Sciences. He has published 51 papers in international journals related to glass science, bioglasses, presented papers, oral, poster, invited talks at 96 national and international seminars, including one at Pardubice in Czech Republic. Recognized as a guide by Acharya Nagarjuna University and Krishna University. 7 scholars have completed MPhil and 3 PhDs under his guidance, and 3 more are doing their PhD degrees. Completed one UGC minor research project on bioglasses. He has also had a prolific professional career with many accomplishments to his name. Baskaran sir acted as a resource person for the refresher and orientation courses at UGC Academic Staff College, SV University, Tirupati, for over 30 times on the topics such as applications of information technology in higher education, IT in research, IT for office administration, MS Office tools, and e-learning, a tool for effective teaching and learning. Prepared the courseware for the information and communication technology, a common course for all degree programs in AP. This material is being disseminated by AP State Skill Development Corporation, AP SSDC. He has experience in teaching BSc Physics subjects for 31 years and MCA, Bharatidasan University, for 5 years. Delivered guest lectures to the students of 10 colleges and 3 universities on topics such as physics behind IT, optics in daily life, e-resources for teaching and learning. Also served as the editor of Andhra Loyola College newsletter, Loyola Today, and annual magazine. Acting as the coordinator of HEPSN, Higher Education for Persons with Special Needs project, and UGC-sponsored project. Through this project, helped a number of visually challenged students to get through their studies by arranging scholarship, scribes assistance, computer training. Baskaran sir also visited and presented papers in Poland, Czech Republic, and is a life member of Indian Association of Physics Teachers, Indian Laser Association, Luminescence Society of India, volunteer in Help the Blind Foundation. Thank you, ladies and gentlemen. It's been a pleasure. Now, I would like Dr. Sahaya Baskaran sir to take over.
Thank you, Dr. Pallavi, for your nice words of introduction. And I also convey my greetings to the principal, Dr. Anandalakshmi Madam, and Dr. Elia, my good friend, and also a former colleague at Andhra Loyola College. And I also had a pleasant surprise to see Dr. Easwari Madam. She was also a lecturer in our college earlier. And my good friend, Dr. Ramachandra, who was the first speaker, and other speaker who is yet to join, and all colleagues all over the country who are watching live, and my dear students. I convey my greetings to each and every one of you. So quickly I move to the topic. Today I would like to present some of the basic concepts of physics that help information technology. So this is my plan of my talk. I would like to say something about information technology, and also what all the contributions of physics in information technology. The purpose being, many of our students, they feel that physics is a tough subject. How many of you feel physics is a tough subject? You can type in chat box yes, or if you feel physics is not a tough subject, you can type no. This is just to make interactive. How many of you feel physics is a tough subject? You can type yes in the chat box. If you feel physics is not a tough subject, you can type no in the chat box. Yeah, this is just to make you interactive. Otherwise, if you go on talking also, it will be difficult. It is in online mode, right? So yeah, a few are typing no and yes. Alternatively, you all there are multiple responses. Now, my aim is to prove that physics is not a tough subject, and the way you study physics, the way you relate physics to your daily life will make interesting. That is only my point of view, and I'm also sharing some of the applications. Of course, physics is the core of every technology, and we can derive a number of lessons for our life also. Physics also a philosophy. There are different perspectives for physics. So today I would like to focus exactly on physics behind information technology. So let me begin with information technology. Yeah, it's a branch of engineering that deals with computers and also telecommunications, how we store data in a computer, how we transmit data, all these come under information technology. And of course, this is a growing field. Today we are talking of machine learning, artificial intelligence, and so many other applications are there. In all these fields, you will understand physics is there. This is my highlight, and I would like to prove that physics is there. Maybe I will take 1 hour time. What exactly is the time? Yeah. Right. So now you see a computer. In the computer, we see different parts of that, right? Printer, mouse, monitor, all these things are there. And in each and every part, we see physics. And when you go for communication, when you want to send signals, there again you talk of microwaves. The whole principle of electromagnetic wave, you can understand, you can control, you can transmit only if you understand physics. And also satellite communication. In each and every aspect of satellite communication, OB, WAN, everywhere, no, you find physics. Now, my point is that if you try to relate this, how physics is there in each and every part of it, naturally, physics could be interesting, right? So this is how I try to show some of my presentations. Yeah. So this is a structure of internet. All over the world, we are connected. I'm sitting in Vijayawada, my home, and you are all over India, I believe. And so many students are there, staff members are there, researchers are there. All of us we are able to connect today, thanks to COVID again. And this is because of internet. So all are connected. We are all sitting in different places, but we are all connected. What I speak in my home, you are listening in your home, your office or college. That is again due to information technology, the revolution in information technology. So to highlight some of the aspects, Nobel Prize in Physics 2009 was given to 3 gentlemen. One, Charles Cow, George Smith, and Willard Boyle. Right? What did they do? This is the statement taken from the Nobel website, right? Nobel Prize website. So Charles Cow, he was the one who invented a simple concept. What is the concept? He proposed, and of course, he also derived the theory behind how will you transmit light in a fiber. That's all. How will you transmit light in a fiber, right? So that led to the whole revolution of optical communication. Today, 90% of the world, we are using optical devices, optical communication. That because of that, he got Nobel Prize in year 2009, right? Similarly, there is another 2 gentlemen, George Smith and also Boyle. They have invented something called CCD sensor, right? So the first one, optical communication, the whole lot of thing revolutionized the whole world. This was proposed in 1969. Later, after 2000, from 90 they started, but after 2000, the whole world is revolutionized. Today, 90% of communication is based on optical communication. Nobel Prize was duly awarded to him. And another great invention is CCD, right? Charge coupled device. What is charge coupled device? This is what we are using in our own cell phone, right? We take selfies. We all know whatever, whether useful or unuseful. Nowadays, we are able to have number of pictures, photographs, all these because of this charge coupled device. This you study in your degree also, but you have to realize when you take a selfie, this is what you are studying in your degree curriculum, right? So charge coupled device is very simple. When light falls, light we call them as photons, right? So there is something happened, right? So it is related to when light falls on a charge coupled device, right? So that induces something. I'm not going too technical, but I would like to make a popular lecture, but still you can read. So when you take selfie, that is again a charge coupled device phenomena. When photons fall, the charges are released and they can be controlled. Using that only you are able to record all your images. To understand all this, to understand how the data is communicated and how we are able to achieve all this, we should understand something about digitization. There is a difference between digitization and digitalization. What is digitization? Right. So in computer or any digital device, right? Any digital device, everything based on zeros and ones, right? We also call them as bits, right? So converting, right? So converting this one, convert, I'll use a highlighter, yeah. Converting text, voice, pictures, everything into zeros and one is what you call digitization. Convert them into digits. Here digit stands for binary digits, zeros and ones. So in a computer, if I type, or any cell phone or any digital device for that matter, not necessarily computer, any cell phone, all are now unified right now. So any digital device, if I say hello, how are you, inside it is not hello, how are you, it is the ASCII code of this particular thing, which is again zeros and ones. If I keep a picture, whether you take a photograph or you scan them and you are downloading from internet, inside the computer, this is also zeros and ones. So converting text, voice, pictures, everything into zeros and ones is what you call digitization, right? Digitalization is slightly different. Here we also talk of digitalization. So how we use this conversion into a business process. You are able to do a business. You are able to have Amazon, right? You order from home, you get. But in the backbone, your order is zeros and ones. Amazon is getting your address in the form of zeros and ones. But properly, everything is made into a multi-billion business. So this is what you call digitalization, right? There is a slight difference. But now I will try to give a physics point of view, how you are able to convert this. 1 second. Highlighter, yeah. So now let us say I speak. My voice, we all know in physics, is a sound, right? Sound is nothing but a waveform, right? A waveform. And a waveform again can be decoded into a combination of sinusoidal waves, right? This you understand from your first year mechanics, Fourier analysis. Your complex wave can be decoded into a number of sine waves. Now let us say this is one piece of sine wave. So this is again a representation of a sine wave. This is nothing but some kind of signal. So how do I convert this signal into zeros and ones? Yes, so this is just to impress you how everything is becoming zeros and ones. Now the signal is this, right? I think you see this, right? I take the highlighter. Yeah, highlighter is there. So this is a signal. The signal is like that. For this signal, at different intervals of time, we take, which you call a time period, at different time intervals, which you call them as time period, you take samples, right? So at this time, the amplitude of the signal, otherwise the displacement at this point is 6.5. After t seconds, after one period, the time, the signal drops to 3.33 and so on. So this is a variation of the signal. Next step in the digitization is the 6.1 is quantized. What is quantized? It is almost something like you can take, this is a rounded off, 6.5 rounded off to 7. It is quantized or it is rounded off to next integer. 3.3 quantized, again it becomes 3, means rounded off to 3. Like that, we have a number. So your voice, which is a signal, is again converted to a number. Number 7 is a decimal number. can be converted to a binary form. Yes, you all study of course in 10th class, now it is available. Decimal can be converted to a binary form. 7 in decimal binary form is 111. 3 in decimal converted to 011. Now your voice, a part of a signal, and a signal is quantized, and this quantized is once again converted to zeros and ones. So your voice is in this form. Yes, so this is a beauty of digitization. Now how do I get my voice back from digits? This is the original signal. So from the digital signal you are decoding. Yes, so in the process of decoding, first 111 111, so the signal is standing at 111. Next time it becomes 0. This is something graph between 0 and 1, right? So the amplitude changes in the digital form as 111 011, again 0100, something like that. The whole signal can be converted into a digital form like this. This can be decoded. From this you can have a decoder. From the decoder, it's again an electronic circuit. From an electronic circuit, from this digit you can get back the wave. What is your wave? The wave is nothing but your voice. So a voice like this can be converted to zeros and ones, and zeros and ones can be decoded into your voice. This is what you call it as digitization. Yes, so but in physics, of course, there are other techniques are also used. This is not the only one. This is one thing. Some of the techniques I will try to explain so that you will understand better. Now, for example, if you take current flows in a wire, can you type if current flows in a wire, what all the things will happen? Suppose current flows in a wire. The wire is connected to a heater. What will happen? Heat will be produced. If the wire wherein current flows is connected to a bulb will glow, right? So this is a simple physics phenomena. All right, you can always interact. If you feel like, you can also, I'm also watching the chat parallelly, so you are welcome. So you can type in a chat box, right? So when current flows in some part of the wire or inside the chip or inside the computer, that can be represented as on state. At this moment current flows, so I can call the wire or that particular device is in on state. Suppose there is the next moment current doesn't flow, no flow of current, I can call this is in off state. Similarly, 5 volts DC normally taken as high. High is not 230 AC. 5 digits, 5 volts DC itself inside the computer is treated as high. 0 or very less, 0.1, 0.01 low voltage is taken as off state. Similarly, magnetic storage, this I will explain with the diagram. Reflection of light in a compact disc. If light falls, light gets reflected. We all study in optics about reflection of light, law of reflection, Snell's law, refraction, all these are happening. Everything is applied here. Light gets reflected, that is on state. No reflection, that is off state, right? So using this, what you can do, you can construct a small devices. For example, in a transistor, you all study in the transistor in intermediate itself. So the transistor can be driven to 2 different states. One is on state or conducting state. Other one is off state, which is cut-off state, saturation state and cut-off state. So these states can be represented as 1 and 0. So a simple physics phenomena, you can put into a circuit. This is a transistor, and the transistor can be driven based on biasing by keeping proper input voltage and proper conditions. This we all be studying: common base, common emitter, common collector, number of conditions. All this I'm not going to technically, but when you study common base, you understand something happens there, right? So this kind of idea can be converted to the transistor can represent zeros and 1. Saturation state 1, cutoff state is 0. That's all. And this is integrated. Millions of transistors are integrated into a small chip called IC. So inside IC, this IC, this is as a symbol of this picture you are seeing, right? So this is an IC. This IC will have millions of transistors. For example, the latest chip can hold 1.2 trillion transistors. 1 trillion is how much? 1 lakh crore. 1 trillion is million times million. Otherwise, 1 lakh crore. So a small chip like that, the highest one, latest one, can hold, that is the technology of today, 1.2 trillion transistors, which means 1.2 lakh times of crores is the capacity. So, but in this process, you should understand the whole lot of physics is there, starting from thin film technology. My good friend Ramachandra has talked about the nanotechnology and how we control these things. Everything is there inside this thing. And again, understanding physics is very important. Now, the point is, as I told you here in this table, there are multiple conditions. They are again a sample, but there are different other conditions too. They are all called on state. The opposites are off state. The on state is represented as 1. Off state is represented by 0. Right? The zeros and ones are called binary digits, in short, bits, the first 2 letters and last 2 letters. So zeros and 1, 0 and 1, they are called bits. But if you want to represent everything in terms of zeros and 1, it will become too complex. It will become difficult. So we also have got some kind of terminology. 8 zeros and ones. This, of course, you all know from your LKG. Nowadays, everybody starts with this only. 8 bits is equal to 1 byte. 1024 byte is equal to 1 kilobyte. Likewise, 1024 kilobyte is 1 megabyte. Then 1024 megabyte, gigabyte. 1024 gigabyte, 1 terabyte. So we always use this terminology when I say the hard disk having 1 TB. Then you should be able to relate what is 1 TB. 1 TB is equal to 1024 gigabyte into 1024 megabyte into 1024 kilobytes into 8 zeros and ones. Calculate for yourself. 1024 into 1024 into 1024 into 1024 into 8. Those many zeros and ones you can hold in your hard disk. Hard disk you can keep in your hand. You can hold a hard disk in your palm, right? So, or external hard disk otherwise. So this kind of technology is right now available thanks to physics again. This is a thing. So what are the principles used? How we are able to make this much of terabytes into a small device or disk is again we apply what all we study in our degree: optics, magnetism, solid state devices, display devices, optical computing. These are some of the principles. One by one, let us see. First, let me begin with the magnetic storage. How data means you should always relate zeros and ones. How zeros and ones are stored into a hard disk, old technology. Now, recent one is SSD, solid state, that is entirely different. But this hard disk, I mean the old technology. Of course, still computers are having both type of hard disk with a SATA hard disk, as well as the latest one is SSD, solid state device hard disk. This is old type, magnetic storage. How the magnetic storage is done, right? Now, we all study the basics of physics. Now, when current flows in the form of a coil, what will happen? This will become a magnet. We all know that when current passing through in the form of a coil, degree intermediate school also we study current passing through in the form of a coil, a DC current, I believe, a magnetic field is created. If you reverse the direction of the current, magnetic field will be reversed. This is a simple concept we study and we mug up and study, but that you should be able to realize this simple idea, all the concepts of Michael Faraday to the latest one, Tesla. Every concept what you study in magnetism is used in storage, or you are using zeros and ones. How? Now let us say I allow current in this direction, maybe clockwise. This I assume if it goes like that, it is a clockwise direction. Now I bring the this one. This is something an electromagnet. Actually, it's electromagnet. This is called read-write head. This read-write head I want to write now. This read-write head is brought to this position. Here, this is a magnetic coating, a small magnetic coating. In this, we can imagine two nearby band, a small space. This may be in the order of some 1 millimeter, no, sorry, 1 micrometer or even less, right? Very small band, a small area. So this band and next band both having uniform dimension. Let us assume it is 1 micrometer. This is another 1 micrometer. These two spaces with that 1 micrometer, all the bands here are produced. Okay, all these bands are produced with magnetized. Means when you bring this electromagnet here, the small tiny dots here are becoming small magnets, small magnets. So let us say this is south pole and north pole. The heads are north pole. The magnetic direction is like that, south and north. The next band here, the tiny magnets are in the opposite direction, south and north. So you create two bands by magnetizing. What is magnetizing? You take a magnet. I think somebody is also drawing along with me. Yeah, please avoid it. Yeah, I'm not drawing, but somebody else is also co-drawing. Please don't use mouse. Yeah. So now these two bands are magnetized. These two bands are magnetized. This magnetized means here the magnetic orientation, a small tiny magnets are like this, south north, south north. Here it is north south. So two bands, successive bands, if they are in opposite directions, means the tiny magnets here are in opposite direction, that represent a zero state. So zero state is opposite. This is again by comparison. This will leave it. Now you take these two. Now these two bands, two successive bands, the magnetic field are stored, otherwise the magnetization takes place in such a way the two bands are in opposite direction. This represents zero state. The next two, yes. So if they are in same direction, that will, no, I think it's wrong. No, these two you have to take as reference. Sorry. These two are taken as reference. The first two, these two magnets are in same direction. This first two bands are in same direction. Same direction represent 0, and the next two, you take these two, they are in opposite direction. This represent the one state. Next, once again, they are in same direction. So here, left, right, or right, left is not important. Two successive bands are in same or opposite. Same direction 0, opposite direction 1. Here again same direction. Next two bands are in same direction 0. Here they are in opposite 1. This is how you are writing your data. So when you copy something on a hard disk, inside the read-write head is moving. Physically it is moving. At every moving is up to micrometer level, you have to understand. But this kind of spaces, within that spaces, the magnetization takes place and the small tiny magnets are created and they represent zeros and ones. This is how data storage takes place in a magnetic field. This was there in 1950s onwards. But later, 1988, some beautiful phenomena called giant magnetoresistance was discovered by two gentlemen, Albert Fert and Peter Grahenbeck. One German and one French, I believe. So these two gentlemen have invented giant magnetoresistance in the year 1988. This technology, giant magnetoresistance, is right now used in hard disks, right? And they were awarded Nobel Prize in the year 2007 for this particular discovery, giant magnetoresistance, Albert Fert and Peter Grahenbeck. Right. So what is the giant magnetoresistance? Of course, in MSc, this is there in some of the places, some of the universities. When you have a very weak magnetic field, a small magnetic field gives rise to a large variation, major difference in electrical resistance. A weak magnetic field changes gives rise to a large variation of electrical resistance. This is called giant magnetoresistance. Right. A small magnetic field produces a giant resistance. This kind of property is available, and there are material. Again, you should go for materials research, and using that, they are able to have GMR effect. And now this is one comparison. 1956, maybe, you know, now they might have been at 64 years old. When they all born 64 years back, the 5 MB hard disk would be this much size. Here there is a reference scale is there. Now you have a hand. Now imagine. So it is almost like my height. 5 MB storage in 1956 would have been like this. This I got it in internet yesterday. And now 2013, 4 TB. Now you should be able to relate to MB to TB. MB, next is GB. GB is TB. 1024 MB, 1 GB, 1024 GB is 1 terabyte. Imagine, they are not simple one. MB to TB, this hard disk is available in your hand. You can hold 4 TB in hand. This is again 2013. 2020, same size of hard disk can hold up to 8 TB. Nowadays, 8 TB hard disks are available and they are in market. But in this kind of revolution, in 65 years or 64 years, you are able to make this much. And if you compare the physical terms, this is 1024 into 1024 times bigger. Nearly 1 million times bigger. You understand? But size has become too small. And this is another comparison. 1990, perhaps when I joined in Andhra Loyola College as a lecturer, the highest capacity of the hard disk was less than 1 GB. 1 GB hard disk. That is, those days we used to have MB only, megabytes. But still, the highest one would have been something like off GB, something like 512 MB. 512 MB, am I right? Yes, 512 MB was the highest one in 1990. But by the time 10 years are over, you imagine how the technology grew. Within 10 years, the highest technology was about some, let us say, this is 18 graphically, 18 GB. Yes, this is in GB. This Y scale is in GB. Now, next 10 years, 2010 started in terabyte. Now you understand 1024 GB is 1 terabyte. 2010, the highest hard disk capacity was something around 4 TB. 2010. Now 2019, the highest capacity was last year. It was again something around 16 point some terabyte. Presently, I searched yesterday, internet says August 20, the largest hard disk what is available in the research or in some specialized system is 18 terabytes. So each time, each year, the technology is increasing. You are able to make a better hard disk, better memory, better processing. How is this possible? Right? Now you should search for magnetic material research in your Google Scholar. Now, yesterday I tried this also. If you try magnetic materials research in Google Scholar, you have something around 32 lakh research papers. Google Scholar gives only scholarly articles or research papers, right? So about 32 lakh research papers are there on this wide area that include nanoscale magnetic material, advanced nanostructures, magnetic material fundamental application. Maybe this is a book, I believe. So some are available. PDF you can even download also. So this is a beauty. Everywhere, all over the world, physics people, not only physics, material scientists, nanotechnology, even chemists, they all do a lot of research. Because of their research only, we are able to have this kind of sophisticated technology. 1990, when I joined in Loyola College, the capacity is off GB. Today, I have still 7 years to go. Now the capacity is 18 TB. You should understand, this is GB, this is TB. Another 7 years, I don't know what will come. So all this is possible because of the research that took place in physics, chemistry, material science, nanomaterial, everywhere, right? The combined fruits of physics as well other allied subjects is what we are enjoying, right? Now, the second thing I would like to highlight is optical storage. How many of you know? You can type yes or no. Okay, I want some interaction. How many of you know how your photograph is stored in a CD? Of course, now CD also outdated. DVD is there. DVD also sometimes outdated. How many of you know that how your photo or a film, some Chiranjeevi film, is there in one DVD? How a Chiranjeevi went inside DVD? Don't worry, any actor for that matter. Yes, I know. Very good. One response is there. Anybody else?
Sir, you can interact now itself, sir.
Yeah. Correct.
Yeah, you can take questions now.
Question, yes. Yeah, you can always type questions also. If you have any doubts in between, you are also welcome. But I don't know how much time I have. How much time I take, Elia?
Maybe 10 more minutes, sir.
10 minutes. Huh?
Is it okay, sir?
Now what is time? 12:20, 12:40. Okay.
Yeah, yeah, surely, sir,
But
surely.
only thing is I have to cut something.
Yeah,
That's
yeah.
yeah. I will go quickly. Let us try, because now the concept is CD works based on zeros and one. Every digital technology zeros and one. Starting we have seen. Here again we are having an infrared laser. Laser is our subject only, physics only. Understand? So infrared laser. Laser you already know. Einstein gave the original theory for the laser, and 1950s the first laser Neyman and others have created, and now it is again after 60-70 years the whole laser industry is revolutionized. The same laser, infrared laser, is used in CD also. How do we write data? For example, if you take a CD, it looks like one layer, but it is a composition of 4 different parts. The first one is the bottom layer is a polycarbonate disc. Yes, polycarbonate is something like a polymer. Polycarbonate is a polymer. Something like your water bottle is a polycarbonate. Same kind of material. A polymer coating is there. Just above that, you will have a aluminum disc or some kind of reflective layer. Just above that, you will have a lacquer layer, which is nothing like paint or varnish, just to avoid oxidation process. Just above that, you have the label, the name of the movie, cinema name or audio. All these are printed. Now, how do I have zeros and ones recorded in a CD? The process is very simple. You have a laser beam. E is the laser beam, polycarbonate disc. This laser beam is sent through the polycarbonate disc, and it is focused on the aluminum disc. When a small laser is focused, low intensity laser, of course, is focused on aluminum, it will make a hole, right? So if I want to write a 0, laser will be focused. Wherever laser is focused, it will make a small hole called pits, technically called pit. Pit is something low-to. That's the pit is a small hole. And otherwise, it is a polished one, a flat surface. So pits and flats are there on the disc, right? Now, so when the laser is focused, a small pit is made. Otherwise, a flat surface is there. So you can call this pit and flat. Otherwise, some other technology name is also used, pit and land. Land is a horizontal surface, and pit is something low to something like a hole is made. Now, this is what CD. So, whole movie is in the form of holes and lands. That's all. Now, how do I read my data back? Right. So, for that process, once again, you allow a laser, but this is still a lower power compared to making hole. You need still higher power, but this is an infrared laser. This infrared laser is focused on a glass plate, and this glass plate is sending back upwards. This is something like your Newton's rings experiment. Second year optics, you may be doing a Newton's rings, right? So, or air wedge experiment. So, just try to relate that. A glass plate kept at 45 degree will send the laser beam upwards. Now, if it is a pit, what it will do? The laser will be diverted to different directions, because it is not a horizontal surface. If it is a flat surface, it will reflect it backwards. Since it is a curved surface, the laser beam is directed to different directions, so nothing comes in this direction. If there is a pit, no reflection on this side. Take the land, a flat surface. Again, same process. Laser is sent, a glass plate at 45 degrees focused. Now, laser is falling on a land, a perfect horizontal surface. When it is fall normally, the light will be reflected backwards. So, two things are happening. Land will reflect the light backwards. Pit will scatter the light in different directions, and nothing will come here. Now, you have light. When light falls on a photodiode, we all know light falls on a photodiode. Something happened, variation of resistance, a small current is generated if you connect it to the circuit, or a small voltage is generated. So there is a response whenever light falls on a photodiode. Whatever is the response depends on circuitry. Now light comes one state. No light, zero state. That's what we want. The whole film, Chiranjeevi's movie or Pawan Kalyan's movie, is in the form of zeros and ones, and zeros and ones are recorded in the CD. And at the time of reproduction, I want to watch the movie, laser is sent, light does not reflected zero state, light reflected back one state. That's what we want, right? Now this is again a technical data. The depth of the laser is very small. No, you can't see the hole. Then you may ask, I don't see the hole, because the hole size is 100 nanometer. The hole size is in the order of 100 nanometer. Width is again very small, little bigger of course, 500 nanometer size. So you can't, your eye cannot see, or your finger cannot feel 100 nanometer and 500 nanometer. So you don't see them, but that is what happening on the CD. Do you agree? So physics is behind, yes or no? Right. These are some more technical details. Want of time, I will skip them. Right. So again, a little advanced version is DVD. But of course, now last 2 years, even DVD is out of place. DVD is again same idea. Optical storage. This is DVD again. Optical storage means zeros and ones are stored using laser. Light is coming. One light, there is no light, zero. But here the DVD, what is happening? The bits are small in size compared to CD. They are still smaller. So you can have more zeros and ones, more space. Otherwise, more data can be stored. Right. But the latest ones, latest means last 5-6 years, again, we have another kind of thing that is also used as a hard disk as well as a flash drive. This is called solid state memory devices, SSDs. Yes, what a common name is SSD, and you also have a hard disk which is also called SSD, right? SSD, solid state drive. They are also there. The both are mixed up. They are also called solid state drive, otherwise solid state devices. Both mean same. Here again, we are using the concept of sorry.
Sahaya Baskaran, sir.
Yeah. Some problem. Yeah, it is coming now. Okay, is it visible?
Yeah, it's visible, sir.
Yeah. Sorry, I forgot to keep the power on. Yeah, now I got it back. Right. This is a problem with technology. Now I think visible, right?
Yes, sir.
Yeah, I use 2 laptops, one to see, one to derive, but I forgot to keep the power on. Right. Now, sorry. Now, this pen drive is again our own physics phenomena, right? So there we are using a concept called field emission, right? Field emission. You all study this field emission in intermediate also, but you should relate. That field emission is used. My voice is audible? Elias, sir?
It's audible, sir. It's audible.
Yeah. Right.
Yes, sir. Please continue.
Sir?
Yes, sir.
Okay, fine. So the field emission is nothing but you can electrons can be induced by an electrostatic field. Simple. If you keep a negative potential, electrons will be pushed. If you keep a positive potential, electrons will be attracted. Simple concept. Electrons are attracted by a positive field, electrostatic field. This is what you call field emission. This is used in pen drive. Technically, it is called EEPROM. EEPROM stands for electrically erasable, programmable, read-only memory. It's a technical name. We call it pen drive as well. Some different version is called flash drive. Both are similar, but slight variations are there. Now, what is happening here? You have a NAND drive, NAND gate flash memory. This is a semiconductor memory. This is storing the zeros and ones. How they are storing? Suppose you have a control gate, right? Here, this is emptied, which means now it is not attracting this electron. Electrons are here and no electrons are here. This represents a zero state. Now you give a gate voltage, you attract them. attract the electrons. The electrons are attracted and they go inside one particular area. A group of electrons are there. This represents one state. So NAND flash memory can represent 0 state or 1 state. Electrons are accumulated, that represents a 1 state. If there is no electron, that represents a 0 state. It's a simple explanation, but of course there are technically you will be studying about gate, drain in your third year optics, this one electricity, transistors. So there you try to relate this into your idea. You can always find this in the YouTube internet also. So such kind of devices wherein you control the electrons by using an electrostatic field, by attracting electrons, keep them, by pushing the electrons out and keep them empty. You can represent 1 state or 0 state. This is used in solid state drive as well as the pen drive. This kind of thing is inside. There are again 2 variations. If you are keeping inside the computer permanently, that kind of thing is called hard disk. But this SSD hard disk, solid state drive hard disk, is the new generation one, which can store, of course, compared to hard disk, less one, but the speed will be more. You can access the data very quickly. This is the advantage of solid state device, right? So now we have another thing called digital images. Now, how do we store our Talaivar into our 31? So into zeros and ones, right? So the idea is very simple. You are keeping any picture. I've just taken this, but no other special reason. I'm not a fan either, but of course I like him, no problem. So this particular picture of one actor, Talaivar, can be kept on a scanner, right? So when you are keeping on a scanner, what is the process that is going on? Each and every dot represent, if I magnify this face, it will become like this. And if I magnify, once again, this is the dots like this. The scanner will look at the picture in this form. For the scanner, each dot is a composition of some colors, right? Depending upon the color, we know the color physics. 3 basic colors can produce any color, RGB, red, green, blue. So depending upon the content of this red, content of the green, content of the blue, a code is generated. That code is the zeros and ones. That code is what picture is. So any picture inside the computer is decoded in the composition of RGB, depending upon how much red, how much green, how much blue, and of course other parameters are also there. Hue, saturation, luminescence, intensity variations are also taken into consideration. A code is generated. So a picture inside a computer is zeros and ones. Any picture, you take your own picture or your favorite hero's picture, all inside computers are zeros and ones only. This is life. Now composition, of course, this is a basic color physics you are studying in school also, that you try to relate. If you want yellow, you need to mix red and green. Otherwise, yellow will have 50% of red and 50% of green. So any color can be decoded. This is a basic idea. Based on this concept only, your display devices are useful. Display devices are existing. You are able to see the pictures back on the computer monitor or on the cell phone. That is using display devices. So one such display device, old, of course, when we studied in the college we have, but right now nowhere it is used in real life. This is CRT, cathode ray tube. Cathode ray tube will have 3 electron guns. The 3 electron guns will fall on a phosphor. Phosphor will glow red, green, or blue, depending upon on which the electron are focused. So this is controlled by electrical circuits, potentially supplied. Magnets are also there. By using this, you can create images. So everything red, green, blue, that's all. So by having 3 electron guns, you can create this kind of images. Each dot on the picture represents a particular composition. Accordingly, the picture is reproduced. This is a CRT. Liquid crystal is another one, LCD display. In LCD, what is the concept? Now you have something called nematic crystal, nematic liquid crystal. The nematic liquid crystal has got the property of orienting the plane of polarization. In polarization topic optics, you will be studying a crossed polarizers. This is one polarizer. You are able to see this is a polarizer which is in the horizontal direction. This is another polarizer which is in vertical direction. Something like you have two polarizers in the crossed positions. Light will not come. But when the pneumatic liquid crystal is in between, the pneumatic liquid crystal is twisting the plane of polarization. So by the time the polarization is, previously it was in horizontal while it entering, slowly it is twisted. When it comes like that, it will come out of that, so light will come. So if you have some light which is called backlight, the backlight will be visible if I keep the electric field off. Now if I keep the electric field on, if I keep this electric field on, what happened? There is no orientation, there is no twisting of the plane of the polarization. So in such case, what happened? Light will not be there. So by keeping the electric field between these two polarizers off state, you can see the light. By keeping the electric field on state, you cannot see the light. So whatever is in the backlight, you can either see or you cannot see. So this will be one small dot, right? So that dot will be red or green or blue, depending upon the light that is coming from the backside. Accordingly, you see one dot. For one dot, you need to control like this. So imagine the whole picture screen. Depending upon the resolution, you have number of dots. Each dots are independently controlled to create the full image. This is a beauty. So here again, liquid crystal is a big area. My MPhil is in liquid crystal. Plasma panel, also similar technology. Red, green, blue, all the three plasma panels are also same kind of thing. But here, once again, we are using a different concept. For want of time, I skip that. And LED screen is again LCD only. LED screen is also an LCD technology. But in the backlight, instead of CCFL, cold cathode fluorescent lamp, we use LED light. Now, compared to CCFL lamp, we are using LED. LED is a power saving. So LED screen is also one of the thing. But LED screen, the technology is LCD only. That's why when you buy LED, you will see LCD screen with LED backlight and that's the thing. But now common language, we call them as LED screen. This is also one of the beautiful technology. But the past few years, we are also getting OLED displays. This is a LCD display. This is OLED display, right? This I got it from internet, of course, this advertisement. But here you can see better resolution will be there. But here again, what is the concept? Each dot is a glow. Each dot is glowing independently. Here, whatever is at the backlight, they are controlled, LCD. But here, each dot glows independently. So this is some kind of OLED technology, and OLED will have a better pictures. That's what they claim. Of course, cost is too high, right? Then you also should understand physics is useful in case of networks, right? That is our okay. In the networks, what we have is how we convert. No, this computer can understand zeros and ones. Another computer is there that can also understand zeros and ones. Both computers are connected by a wire, right? Both computers are connected by wire. So whatever is in this, the data can be transmitted. This is what we call simple term network. We also have different depending upon the sizes. Whatever is the network, how zeros and ones are transmitted. Concept is again physics. We use the total internal reflection, ultraviolet rays and all. Total internal reflection is used in where optical cable. Yes, in optical cable, this is a very simple physics phenomena. When light travels more than its critical angle, this is the critical angle. If the angle of incidence, this is the normal, is more than critical angle, it will be completely reflected. This is what you call total internal reflection. This total internal reflection is used in the optical communication. Laser is sent and this is completely reflected backwards, even 100 kilometers, 1000 kilometers it will go. This is nothing but your optical fiber. So the technology behind our present communication is simple physics phenomena, total internal reflection. But it's not that simple. You need a laser. That laser should have sustainability. It should give zeros and ones. Zeros and ones means on off like that. that data should be communicated. The laser, the optical fiber should have a proper material, the cladding, core, all these different technology again. Okay, I will skip that. So the whole idea is when you speak into zero, you are creating a voice. This is your voice. This is converted to zeros and ones. The first slide I show you. That electrical signals are given to a photodiode. The this is a laser again. The laser is giving zeros and ones. Total internal reflection takes place, and that goes to a photodetector. In the photodetector, once again, zeros and ones are reproduced into an electrical signal and decoded. Now you get back your voice back. So when you speak and your friend receive, the whole thing happens in between. The whole thing is physics only. Laser, physics. Photodiode, physics. Optical, transmission, total internal reflection, physics. So when you study total internal reflection, try to enjoy everything is happening. I just quickly try to give some recent advancements. One such thing or the future of computer is going to be quantum computing, right? Quantum computing, what we are using in ordinary computer, the digital computers, we are talking of zeros and ones. Zero, one such of electrical, high voltage, low voltage, some kind of condition. But in quantum computing, what we are using is quantum states, right? So the quantum phenomena such as superposition of two signals or entanglement, this you will be studying in your degree. This is used for computation. Such kind of computers using the quantum technique is called quantum computing. Yes, this is the future of computing. Already some IBM and some of them, they claim that they also have got, they have made a quantum computers, and this is a future of this one. And the next technology, yeah, this is in the quantum computing, we are using qubits, not bits. They are called quantum bits, and that can be a state, quantum state can be of any level. So that can represent more number of zeros and ones. Yes. So this is of course in research level, some companies they claim. Another set of area which is you are going to have in future is optical computing. What is optical computing? The light is used instead of electrons. In a digital computer, flow of electrons are there. In optical computer, photons are there. Light, photons, of course from a laser beam, that will be represented to represent a transistor on state or off state. And this is again got a lot of advantages. Speed will be trillion times bigger. All these are happening. So by the time I retire in another 7 years, I believe these computers also will come into market. So dear students, and yeah, this is one thing. The latest one, yesterday I was searching for that. What is the highest capacity? They were telling 1.2 trillion transistor. That is 1.2 lakh times crores. 1 crore, 1000 crore, lakh crore, 1 lakh crore, 1.2 lakh crore is the transistor that you can accommodate. And of course, Apple also has got another kind of thing called bionic chips that has got 2.36 gigahertz, the frequency of the clock. Clock already the computer students know. Clock is the one which decides the speed of the computation operation. Every process inside computer, microprocessor, we also study that, determined by the clock speed. Clock speed is high, the operation also will be faster. So this capacity is 2.39 gigahertz. That's the speed. But this is not simple thing. This is again you use a crystal oscillator. Crystal is an important area. Crystal growth. You need to have a single crystal that can have this much of thing. Only that Apple knows that. We don't know that. It's their own research, and that's why Apple phones, Apple cost laptops, Apple devices are very costly. They all these companies invent, and they all make. Elia, I have come to conclusion. So
yeah, sure,
all these are making great profits. Understand? So my dear students, my point is very simple. When you study physics, you should realize physics is the backbone of all technologies. The whole world is moving because understanding gravity to understanding the latest iPhone technology, but especially information technology. Every bit of physics what you study in your degree PG is used, and study the subject with some interest. Never say physics is boring. Never say physics is tough. Physics is such a beautiful subject. Understand physics, and you also need the need of the hour nowadays is not information. Previously we need to memorize. When all study, myself, Elia, Elia is younger than me, but still other staff, they used to mug up things, but now no use at all. Yesterday I worked for 5-6 hours. I got beautiful information from internet. No need to memorize. How you use the information creatively for creating new technology, new devices. That is how Chinese are becoming powerful. If you can do that, if you can adapt that, India also will become very powerful. So once again, I thank Dr. Elia and Principal Anandalakshmi Madam, all the organizers for giving this wonderful opportunity to share with students. I targeted students, staff, those who can also imbibe some of the applications so that they can also use them in their own teaching. Of course, it is not a completely my own research. It is a popular lecture. Number of websites are also there in the internet. You can always search, no need to remember anything. Simply go for physics, everything is there. Nowadays, especially COVID situation, we also have got virtual labs in physics. All these, if you use, you can understand, you will again say physics is interesting. Thank you. Thank you,
Sir,
Elia.
thank you very much, sir, for that wonderful presentation.
Thank you, sir.
Thank you so much for taking us through
Exactly 45, I finished, yeah.
the physics behind information technology.
Yes, sir.
At this point of time, I would like to highlight 2 points. One is Dr. Sahaya Baskaran sir completed his MCA when there was no demand for MCA long back, and when people doesn't know what MCA is. And second point is when people doesn't know what PowerPoint presentation is, he made PowerPoint presentation in Andhra Lela College, creating interest among the faculty. So that is his greatness. He is very good at IT, and he has many other degrees also. We could not mention that in flyer. And thank you so much, sir. Thank you so much for this wonderful presentation explaining physics behind information technology.
Thank you, sir. Thank you. Thank you so much.
Sir, may I ask you, sir? I am Balaya from
Surely, sir.
GDC
Please,
Pithapuram.
quickly. We are already running short of time.
Yes,
Third
sir.
speaker is already
Okay,
waiting
okay.
for us.
Yes,
Sir, you
Balaji.
have explained the different concepts of physics, sir, in refraction, diffraction, and a total internal reflection. All these things, sir. But the Indian government has started the Bharat network, sir.
Spark
Hello?
network.
Sir, Bharat network, sir.
Bharat network. Yes, yes, yes.
Bharat network, sir, and
Yes.
fiber optic network, sir.
Yes, sir.
Fiber
Yes.
optic network, sir.
Yes, exactly.
Yes, sir. It is really dedicated to connect the 2.5 lakh villages, sir.
Exactly. Yes, sir.
2.5 lakh. Thousands of crores are being spent on this Bharat network, sir. Government,
Exactly.
Indian government, sir.
Yeah, for medical and education,
Yes, sir.
also
Yes,
economy.
sir.
Yeah, it will boost all these processes.
Sir,
Yes.
sir, there is an INSAT system is there, sir. INSAT system is there, sir. That
Yes, sir.
means satellites are being sent to
Exactly.
geosynchronous orbit, sir. But whereas the fiber network, what is the necessary to connect the villages after expending the almost these thousands of crores, sir?
Yeah, exactly. Yeah, good question. The thing is,
Yes.
we need to have always multiple technologies, sir. Right?
Okay.
With
Yes, sir.
data usage, right? So 2 years back, we never had online class, right? Our need was only talking to a person, which is less bandwidth. But now that the whole online is there, and our students are also expected to have, even villages, our students are there, they also should have more bandwidth so that they can listen. And we don't know, in the future, still other techniques would come. Doctors will be in their home, telemedicine will be possible, the patient will be there in the village. In such cases, the bandwidth usage go on increasing, and multiple needs are always increasing, like our own online education, telemedicine. All these would be possible if we have more bandwidth, and such kind of thing cannot be achieved with one technology. We should have again multiple technology. Also, Starlink, there is another project by Elon Musk, right? So Starlink is coming up. So 5G will be possible with 1,000 times bigger speed than this. So, but the future needs, when you take the future needs, all these must be needed. Nothing is redundant.
Thank you, sir. Thank you
Yes.
very much.
Dr. Sahaya Baskaran sir, thank you so much. We look forward working with you.
Oh, thank you, sir. Nice occasion to meet you all. I'm happy.
Hope you will stay for some duration.
Yeah, I will listen to the Hubble telescope. I want, yes.
Yeah. Sri A.M. Shekhar from KJ Somaya College.